Scotch-Choke mechanism that transforms the circular motion of a crank into the reciprocating motion of a shaft, or vice versa. It has been used in a number of different internal combustion engines and in control valves. In this Scotch-Choke shown, the acceleration of point A is defined by the relation A is equal to 1.8 sine kt minus, where A and T are expressed in meter per second square and seconds respectively, and K is equal to 3 radian per second. Knowing that X is equal to 0 and V is equal to 0.6 meter per second when T is equal to 0, determine the velocity position of point A when T is equal to 0.5 seconds. So we are given A equals minus 1.8 sine kt, and when T is equal to 0, we have X is equal to 0 and V equals 0.6 meter per second, and the value of K here is given as 3 radian per second, and we have to find velocity and position at T is equal to 0.5 seconds. So let us start from this relation where acceleration A equals dv upon dt equals minus 1.8 sine kt. Rearrange dv equals minus 1.8 sine kt dt. So integrating velocity v from 0.6 to some value v, and the integrals limits for time t is 0 to some value t. So we have 0.6 to v dv minus of 0 to t 1.8 sine kt dt. So the left hand side gives us v minus 0.6 equals, the right hand side gives 1.8 cos kt by k, limits from 0 to t. So substituting k is equal to 3, we get v minus 0.6 equals 0.6 cos kt. So I will not substitute 0.6 here, I will substitute it later. Minus cos 0 is 1 and this value is 0.6. So v equals 0.6 cos kt. So let this be our relation number 1. Now I can again write v as dx by dt equals 0.6 cos kt. So rearranging, we have dx equals 0.6 cos kt dt, and we integrate from x is equal to 0 to some value, the limits 0 to x between, and integrate in the right hand side between limits 0 to t 0.6 cos kt dt. So this becomes x minus 0 equals 0.6 by k sine kt 0 to t. So x becomes, substituting k is equal to 3, 0.2 sine kt minus sine 0 is 0, so that is 0. So this is our equation number 2. So we have to find the position and velocity at time t is equal to 0.5. So let me rewrite our equation number 1 and 2. That is, for velocity v, we have v is equal to 0.6 cos kt meter per second, and x equals 0.2 sine kt meter. So when t is equal to 0.5, the value of kt becomes, we have k is equal to 3, so 3 into 0.5, that is 1.5. So v now becomes, v is equal to 0.6 times cos of 1.5 radians, this is radians, the value is 42.4 millimeter per second, and x is equal to 0.2 sine kt becomes 199.5 mm. So final answers are x at t is equal to 0.5 seconds, x is equal to 199.5 mm, and v is equal to 42.4 mm per seconds. Thank you.